I'm joined by Peter today. Both of us work at Google. We're super excited to talk about stateful applications in Kubernetes today. And also happy Diwali for all of you in the live stream and the audience who may be celebrating Diwali today. Let's get started. Today, we're just going to talk about stateful applications and in terms of the value prop, what we see as a cloud provider of value customers see running stateful apps in Kubernetes. We're going to take a little bit of sneak peek on our roadmap as to how we're trying to actually improve the quality of stateful applications in Kubernetes, specifically as a cloud provider contributing to Kubernetes. You're going to take a look at a little bit of architecture of how we see modern SaaS applications like database software as a service applications being built on Kubernetes to benefit from all of the modern capabilities Kubernetes offers for stateful apps. And finally, you'll see a demo where we'll kind of show you a sneak peek of a feature which we're working with the upstream Kubernetes community to migrate stateful sets across clusters. I won't take too much time on this slide. I think this has been spoken about enough. Stateful applications and Kubernetes is a thing, and I just want to validate that we see that here as well. It is really an upcoming space. So when we spoke with customers, there are three ways of operating stateful applications on Kubernetes today. The first is customers who want a lot of control. For example, if you're a customer who wants to take the Redis or the Postgres container image, run it as a stateful set, operate it this way, you get control over both the application and infrastructure. It's a complete do-it-yourself kit. And of course, with great power comes great responsibility. So there's a bunch of customers who said, yeah, I don't need this much level of control as a DIY kind of model. I want more support. And that's where Kubernetes operating model comes into the picture, which is like the second model, which we heard from customers. Here, customers share responsibility between themselves and the stateful application provider. For example, if you're using Elastic, you can use ECK operator, which is an operator vended by Elastic, to kind of share the responsibility of running the app. So you get a little bit of a partially managed model when you operate in this way. And finally, we also see a large number of customers prefer managed services. Google is known for the data cloud. Similarly, there we have a large number of managed services burgeoning there. So we see, but also we see a lot of these managed services being built on Kubernetes. So what it means from an end user, you just have a database endpoints, you exchange credentials, and everything is fully managed. But underneath the hood on Kubernetes, it is a large multi-tenant stateful application. So then we double click and ask customers, why are you running these apps on Kubernetes? The DIY customers who are running a lot of the infrastructure themselves and the app, it came down to three reasons. The first is we take this for granted, but relative to VMs, Kubernetes gives you a lot of out-of-the-box capabilities. For instance, we spoke to an internal SRE team here at Google, and they get a lot of stateful primitives, CI/CD, managed Prometheus. All of this comes out of the box with Kubernetes, and it's something which they really benefit from in their day-to-day operations. The second is actually really important, organizational gravity. I'm just going to use an analogy here. Just like the sun bends space-time and gains a lot of gravity and attracts planets into its orbit. Similarly, what we see and hear from customers is as Kubernetes gains a lot of organizational gravity, customers actually want to kind of consolidate their operational practices between stateful and stateless app and use Kubernetes to kind of operate both apps to prevent silos in their organization. And finally, just like the stock today, there's a burgeoning ecosystem which is building and developing around Kubernetes and stateful applications. So we hear from a lot of customers they want to benefit from this as well. Why do the SaaS customers choose Kubernetes? I think the first one is obvious, but also really important is SaaS customers need to run in a multi-cloud infrastructure setting, and Kubernetes really enables that, and we at Google really want to support them. The second is these SaaS customers, if you think about it, are some of the most managed services for data. And they really want to build on modern internals, and they don't want to build all of this on VMs themselves. So running on Kubernetes actually gives them a lot out of the box so that they can kind of modernize their applications. And finally, last but not the least, empathy, of course, because a lot of people, everybody is running Kubernetes nowadays. So it gives these SaaS customers a kind of vocabulary to kind of speak with their customers in shared vocabulary and build a little bit of empathy. So we've taken a look at, the value proposition of why customers run stateful applications in Kubernetes and how we observe it as Google. Now we're going to take a little bit of what we hear from customers at the pain point and how we're structuring a roadmap to really improve the quality of life of these applications. The customer feedback boiled down into three main areas. The first is stateful Kubernetes actually churns nodes a lot, and this is for the better of the entire system because there's scaling, there's patching, there's all of these data operations which is being done at a very fast pace in Kubernetes, which is great for security patches, for being a modern application. But of course, some of these stateful apps are not kind of architected to that kind of level of churn. So customers said they need a lot of safety controls in order to have peace of mind while operating their stateful apps on Kubernetes. The second piece we heard from customers is to run a stateful application well on Kubernetes today, you actually need to daisy chain a bunch of different YAML. And what customers are more looking for is built-in primitives to Kubernetes, and that's where they see there's a lot of value. And finally, storage itself is something customers want fulfilled behind the Kubernetes API. There's CSI, of course, has been around for a while, but customers see opportunity to improve this further in terms of how storage works with containers. So we work backwards from that feedback. There's two layers here. The first layer is essentially the orchestration layer, where we can build in some of these safety controls, some of these data protection controls, observability, and also work with the OSS community to make Kubernetes more stateful friendly. And of course, the second layer is actually the storage layer, where we work at the storage primitives to kind of make them more container friendly, whether it's block, file, or even local storage if you need. Double clicking on a few of these at the first layer, which I presented. Backup is becoming a big thing in Kubernetes today. We're working with the community, as well as we have features out of the box for you to back up Kubernetes today on GKE. And I'm sure you can use partner tools as well. All of them work on GKE today. And this gives you out of the box granular control to back up your data, and it kind of assuages customers' concerns of that peace of mind value proposition. And the use cases here are typical in terms of rollback, zonal failures, of course, upgrades, and of course, compliance, archival for compliance purposes. The second part of the layer of stateful orchestration is coming to upgrades. What we learned from customers is PDB is not optional when it comes to stateful applications. PDB are pod disruption budgets, which allows Kubernetes to kind of account for how much disruption your application can handle. So we see a lot of customers using that. And also we see a lot of customers be successful by using some of the built-in capabilities that their cloud provider offers. Like, for example, at Google, you get built-in blue-green and maintenance and exclusion windows. So you get cloud providers provide some of these. So definitely make sure you leverage some of them for your stateful apps. And then, of course, observability is a big deal in terms of customers wanting out-of-the-box Prometheus. I think Prometheus, as we also learned in some of these other talks, is there's so much value in seeing both the app and the storage metrics all in one stack. So Prometheus really enables that. And we also see customers want more and more simplicity with solutions like Autopilot to really simplify their quality of life while operating stateful applications. And finally, at the storage layer, there's not much here in terms of we are really working on making storage work seamlessly for you so that you don't have to focus on the details. And we are building integrations, whether it's Cloud File Store for your content management, persistent disk for your database, local SSD or instance store, or any sort of local storage for your AI/ML apps or your caches. That is layers where we're working across in the community as well as internally to make it better for customers. So what are the takeaways? The takeaways, what we really learned from customers is the first is day two ops is actually a day one consideration. We see customers who are most successful are the ones who actually consider their decisions on data protection, on pod disruption budgets, on how they view their observability. All of these decisions made on day one. Because they reap their benefits on day two by day two ops becoming a no ops. So that is definitely important for your stateful apps. Second is storage. What we see from customers is there are a lot of storage selection. A lot of customers do use the defaults, but there is a lot of other storage classes out there. So figure out what really fits well for your application, whether it's AI/ML, a content management system, or a database. Third is, of course, you want to actually think about how much much control you need, whether you actually want to DIY an application yourself or use a SaaS and benefit from everything managed. And finally, I think this is where we see like Kubernetes and even the managed Kubernetes from a cloud provider really change the narrative from Kubernetes not being ready for stateful to Kubernetes becoming a platform for modern stateful applications. We've seen the narrative really being changed. And as I'm going to hand it over to Peter, who's going to talk about MariaDB, who's built their SaaS on Kubernetes, and who's going to walk through a demo on how we're working with the open source community to make the quality of life of stateful applications better. Peter, you want to take over?
Sure, yeah. Let me just pull these slides up. So let's talk through a case study of a customer that chose Kubernetes. So MariaDB emerged in 2009 when databases ran on virtual machines or bare metal and Kubernetes didn't exist. And MariaDB revolutionized their architecture using Kubernetes to build a modern SaaS platform for their customers. By leveraging automation that Kubernetes provides, MariaDB is able to reach massive scale and high availability with SkySQL. And SkySQL is a SaaS platform globally available in 29 cloud regions and supports multi-cloud and hybrid cloud environments. So how did MariaDB build SkySQL? Well, just as MariaDB's customers rely on MariaDB to reduce database complexity, MariaDB relies on GKE to reduce their Kubernetes complexity and infrastructure complexity. And all the core components of SkySQL are deployed in GKE, and MariaDB's services are also deployed in Kubernetes clusters. So MariaDB is both a customer of Kubernetes and a vendor. And let me capture a few of their highlights of why they chose Kubernetes in their own words. So number one, multi-cloud and hybrid cloud flexibility. The ubiquity of having Kubernetes enables SkySQL to be delivered to end users across clouds. Modern orchestration. This gives MariaDB the ability to have built-in automation, self-healing of their infrastructure, and safely manage SkySQL at scale. And as Akshay pointed out, empathy. Kubernetes puts MariaDB on the same plane as their customers, as they're used to using the same API. As their customers are familiar with Kubernetes, MariaDB is also using Kubernetes on a day-to-day basis to manage their infrastructure, so they can build bridges to their customers through that interface. So what are we working on? We see customers looking for built-in safe operations on Kubernetes. And one example that is a pain point, stateful workloads, is upgrades. We've seen a lot of customers find challenges in managing upgrades, especially control plane upgrades, and as they're a one-way door. Kubernetes control plane upgrades don't support rollback. This has been an open issue for many years, and it's been challenging to solve. So the community hasn't actually tackled control plane version rollback. And we've seen customers move stateful sets across clusters to gain the added safety of having this option to roll back to a previously known safe control plane version. We've also seen customers wanting the flexibility of moving stateful workloads across clusters, whether it's for cluster rebalancing, maybe they reach capacity limits, or due to feature changes, they want to move to a cluster that has a different feature set or different configuration. And doing this today is a major challenge. There's multiple considerations, as we've seen in some of the other talks about multi-cluster. There's network to manage, there's orchestration to manage, there's storage to manage. As much as we'd like the world to be about Chapter 7 in Jeff's talk, everybody's using object storage that's globally available. It's not the reality today. A lot of workloads are using block-level storage and disk-level storage. So with that in mind, I'm going to roll a demo. We're working on a new building block for Kubernetes to enable these safer operations. And one of the building blocks is a new KEP we've introduced in alpha for 126, targeting 126. And it adds greater control over stateful sets. So it enables a stateful set to be split up across clusters to gain finer grained control during a migration. So let me roll the demo, and I'll kind of talk about what's going on and some of the building blocks in play. So let's see here. So I'll just preface this. On the bottom left, we have a cluster that's running Redis, 6 nodes, or 6 pods, sorry. On the right screen, we have the cluster that we're going to migrate this workload to. There's no relevant objects in it. The top left, we have the success metrics for Redis commit log. And on the right, we have a locust load test that we're going to generate traffic against this instance and see that it maintains availability during migration. So this is rolling at 2x speed. And we kick off the load test. Immediately we see the disk references move over. So these clusters are in the same zone. We're able to reference the same disks as long as we have relevant resources in the same zones. And now we're using this building block that we've introduced to move replicas over. So we're taking replicas one by one and spinning them up in the new cluster. So creating a new stateful set object, creating new data references using PV, PVC, migrating over config maps, and using the ordinals to orchestrate which slice of the stateful set is going to be moved to a new cluster. And this migration, it uses readiness gates, and it uses the readiness conditions of a pod, and also the stateful set, so managing ready replicas and replicas. It's part of the stateful set API to know when it's safe to move replicas over. So if you encounter an issue in new control plane where replicas don't start up successfully, you can pause migration, you can roll back migration, and migration won't proceed unless it's safe to do. So we can start seeing traffic from some of the existing pods start to drop, and traffic start to spike from some of the new replicas. We see the yellow line in the top left corner. That's starting to ramp up as DNS propagations occur for the client. And we can see our request per second stays relatively constant during this migration. So we're still maintaining a base level of availability. Okay, so with that, we're going to close it out. If you find this topic interesting, multi-cluster migration, QR code is a link to a talk that I'll be giving on Wednesday with Matt Schallert of Chronosphere, where we showcase this migration of Chronosphere's M3DB database. And yeah, date and time there. But thank you all for coming out, and any questions, you can open the floor.